Hi everyone. So you got your circuit working on a breadboard or your simulations are working fine, and now it's time to liberate the application from the breadboard or just make an actual circuit. You have two paths ahead. So the first path is you can either go ahead and design a PCB like this one, and it's nowadays it's really straightforward to get a PCB like this one fabricated. It just takes a couple of dollars and a couple of weeks of waiting time. It's really straightforward, but you're not going to get into the details of PCB design in this video. And then you can just populate it with your components as well. But in this video we'll be talking about the second path, which is building a wired prototype. So here is one of my early jobbies. I guess there's like all sorts of crimes happening here on the back. But it works. It's a PIC 18F 4550, I believe, with a bit of powering and an RGB LED and some bypass caps. It's very straightforward, really simple. It's programming headers, but this is like especially for simpler digital circuits. A wired prototype usually is a good alternative to designing an actual PCB, especially for one-offs and one-off projects. It's fine for analog applications. The PCB acts more. It acts like another component of your whole solution. So there's a bit of more. Like you can't just do a wired prototype and then design a PCB and expect them to behave the same way. But with digital circuits, simple ones, one-offs, it's usually fine. But if it's getting too tedious to build a wired prototype, it's a good time to start, considering designing your own PCB, getting it fabricated, and because really it's relatively a very straightforward, simple job to do. But building your own prototype takes a couple of hours, something like this. I don't know, maybe an hour. A bit of tedious work here and there, but and it would work. You will get a working thing. It's going to have some physical connections, everything like sorted, so you don't have the problems of dealing with the breadboard and the flaky connections and all that. So it's a good alternative. And today we'll be focusing on how to build wired prototypes like this one. We will talk about a couple of tools you need, a couple of tips, and hopefully we will build a wired prototype as well. The first thing you need is actually wires. And here I have a 24 AWG hookup wire. It's a solid core wire. So if you just strip that one, as you can see, it's only one wire. There are no strands or anything like that. And this is the kind of wire that you want to use. Stranded ones, such as this one, you just need to put the strands together. It's a little bit more tedious to work with. So for wired prototypes, go for a solid core wire, and its thickness is measured in AWG. It's a bit of an interesting unit. It's American wire gauge, and it's just the thickness of the wire. And you would generally want to use 24 or bigger values. They get thinner, like 24 is this one is 24 AWG. 26 is thinner than this. You can go up to 30. I like 24s because they're easy to work with. They're quite strong. They can take up a couple of bendings here and there, not a problem. They're actually quite easy to strip them and then use them as well. So you also need, after your wires, you also need prototyping boards. You can never have enough of them. They come in all shapes and sizes. So these are just like no pads, no nothing on it. But I usually use these ones with like solder mask and all these holes in there, and just it's pretty much standard 2.54 millimeter holes. There are ones with the holes connected here and there. Again, it's just based on your application. You can just get like some of this and some of that. It just it's hard to get wrong with these things, and they're quite cheap as well. You can just buy like 10 of them for $1 or even cheaper if you like to. Today I will be using one of these smaller ones because I just want to liberate our PIC 10F project. I just want to put a PIC 10F there, a 3.3 volt regulator, and some headers to expose the pins. That's what I want to do here. You just need to make sure that there's enough space on there. Like, just don't go, this is like tiny, but it's enough space for what I'm trying to do. But yeah, it's better to go a little bit bigger, so it gives you enough playing space, and you can just prototype a little bit more as you go along. So that's generally better to get yourself some good space. On the tool front, you obviously need the side cutters. That's like, get one of the smaller ones, because that will not only help us cut the wires, but it will also help us like trim some of the excess leads and all that other stuff while we are building our circuit. And when you are cutting the leads of components and other stuff on your PCB, just beware that these things can like give you some serious projectile damage. So either wear eye protection, or whenever you are cutting something, you just hold onto it and then cut it. I'm just gonna show you in a sec. And you definitely need wire strippers. That's just, you know, like get some wires and like let's strip them. Yep, so that's what it does. You want to get these, one of these automatic ones, and this is interesting. There, like, you can get one for a couple of dollars or a couple of hundreds of dollars, but this is a cheap one. I believe I get it for 20 bucks or something like that years ago. I don't remember, to be honest. It sometimes it like just the cheaper ones tend to get stuck, like this one. This one is like getting stuck, so I have to do this. And the other thing is they won't play it well with thinner wires. With 24 AWG it's fine, but with the thinner wires, I imagine that would damage the cables, and it's not going to be very easy to work with. But this one is good enough. You don't have to go very expensive in that front. And one flathead 2mm screwdriver, which I'm going to use this to just get in there and bend the leads and the component legs, and that just, it's actually a very, very versatile tool. Just need one of these as well. This is called a soldering stand, and this is like the one that I have here is as simple as it gets. You can get fancier ones. They're like with bendable multiple holders and stuff, but you don't necessarily need that. Having one simplifies things a lot, and these simple ones also are quite cheap. It has like a heavy metal stand at the bottom, so it doesn't go anywhere, and then it has these alligator clips that can hold your PCB in place, and these joints are like, you can just screw and tighten them and adjust them, the angles and everything. So this thing is a little bit tedious to work with, because I got, yeah, really cheap, super simple one, but it has served me well. Gave me no reason to buy a more expensive, fancier one. So far so good. That one's good. Let's get rid of these PCBs. You need a solder. So here I have the lead-free one. So they're a little bit harder to work with compared to leaded solder, but if you don't have any lead solder lying around, just get the lead-free ones. Because yeah, it's just, if this thing ends up in landfill, lead isn't great for, you know, groundwater's contamination, and it's generally not great for living things. So even though it's a little bit more tedious to work with lead-free solder, it's better for the environment. And if you don't have any, just get a lead-free one. And you obviously need a multimeter to check your connections and everything. And to connect everything, of course, we need a soldering iron. Well, I have a Hakko one here, and a soldering iron isn't something that you want to go cheap, especially if you are doing frequently this kind of work, because they maintain the heat better, and they're generally very much easier to work with than the cheaper ones. The cheap ones, they just don't maintain the heat. They have safety issues, and they usually die within a couple of years. So these mid-range ones, at least get one of the mid-range ones. They're just much easier to work with, and it will get better results in general. So I'm not going to get into too much of the soldering details. I'm just going to make a wired prototype in this video. But there are heaps of resources out there, like how to do lead-free solder, how to solder. You can just go and watch these videos as well. Let's pop our PCB in the soldering stand. Make sure that everything is nice and tight. So before you start, it's generally a good idea to, you know, just start with a PCB software or some kind of design software, or at least just, you know, write it on a piece of paper, like what you're gonna do, and then you just can do some planning. And before we start soldering anything, we're just going to pop our components there and make some kind of plan. For simple circuits, you don't need that, but for more complex circuits, you definitely need a plan, some sort of schematic or some PCB design, and then it's going to be much easier to work. And you generally want to use through-hole components while you're building wired prototypes like this, because yeah, they're easier to work with. There's nothing wrong with using SMD components. If you have nothing around, just SMD components, yeah, you can just be a little bit creative while soldering onto these pads, but it's going to be really tedious. So it's much better, much easier to work with through-hole components when you're building a wired prototype. So I'm just gonna pop our 3.3 volt regulator here, and I'm just going to follow through this. So this is a very simple circuit. I'm just going to put a regulator here, and I'm just going to put our micro here, the pick 10F here, and then I will just get some headers here, just break out the pins, expose the pins, the power, and all the IO, GPIO pins of the micro as well. It's a good idea to build it layer by layer and give some space on both ends. So if something goes wrong, if you run out of space, you can add can pop in a couple of more wires and solder everything. So just don't go like too close to the corners. I designed the circuit before, so I'm pretty clear on what needs to happen here. But you might need to spend a little bit of time with the PCB software. It could be Fritzing, KiCad, whatever you're. And if it just requires a lot of planning and a lot of thinking, maybe it's a good idea to actually go and design a PCB too, rather than doing a wide prototype. So yeah, I'm just going to put our cap here. So I'm not going to push the capacitor all the way through there. I'm just going to give it a little bit of space, and then I'm just going to bend the leads of it. Doesn't matter which direction you bend the pins, just to keep it in place. I'm going to do the same with the pins of the regulator. So okay, now this is going to be our input cap, and let's put our output cap there. So I'm not worrying too much about the connections. We're still at the planning stage. So I have the LDO, the input cap, the output cap. Both of those are electrolytic capacitors, so you have to be careful about where their polarity is. So they're just both connected to the ground. The middle pin is the ground. They're both to the ground. The next thing I want to do is to pop in our micro here, and for that one, you can just pop the micro right there. But another thing you can do, instead of using your micros or integrated circuits, especially when doing wired prototypes, you can pop one of these IC dip sockets. They just, they have these pins. They're easier to work with. They make everything easier to work with on a wired prototype. So I'm just going to put one here. I think it's enough space. And then the output, I'm just going to use these pin headers. I'm just going to break 6 of them. You can just break it with your hand. It's a little bit, I guess, yep, we got it right. It's usually cheaper to go and buy these longer ones and then break them apart. I'm planning to expose the pins, like first VDD, the 3.3 volts ground, and then GP 0, 1, 2, 3. So that's going to be our 6 pins. And I want to leave this area for a little bit more prototyping. Now we need to pop in our wires to just connect everything. So make sure that when you get your wires, it's generally a good idea to get different colors, so it's easier to remember what goes where. Okay, so with the PIC10F series, first pin here is not connected. The second pin is VDD, so we're just going to connect our power there. I'm just gonna get a little bit of wire, and don't worry too much about the lengths, and it doesn't have to be perfect. After all, this is a one-off wired prototype. As long as you have enough space to fix things later on. And even if, like, yeah, here what happened, the stripper just break the cable, and this is not enough. Basically, you just want to give half a centimeter, at least 5 millimeters stripped wire, so you can just it's easier to work with on the PCB and easier to put it there too. So I'm just going to, no problem, just cut another one and strip it again. Give it a nice 5mm on each end. Yeah, it could be more than 5mm. It's not the rule, but at least give 5mm. Just want to bend those excess bits a little bit under the board, so it just stops wiggling. And we are still not soldering anything at all, just popping in our wires, laying out our components. This is kind of like a PCB design stage. And it doesn't have to be perfect. You can make mistakes, you can fix them. That's all good. Probably a good idea to strip a couple of wires in different lengths and different colors, and then you can just use them. Like, you don't have to do it as you go along. What I want to do right now is just I want to put this, because this thing is wiggling too much. I want to stop that wiggling, so I'm just gonna take it out, flip it over. So these are like the little pins of the IC socket, and using the flathead, I'm just going to bend them outwards like this. You don't have to do it for all of the pins really. Just get some of the leads. Just one on the right, one on the left. That should be fine. Just some of them. Just bend them outwards. You can bend them inwards and use the holes in underneath the IC socket as well. That's totally fine. But I think we have enough space here in this case. And yeah, that looks pretty good. Now this won't stop. This will stop wiggling on the PCB. You just have some sort of a physical connection here. So if you look at it from this angle, I bent some of the pins over here and over here. So now the IC socket is sort of stable on the PCB, and it's not gonna fall down anywhere. I've already bent the pins here and there, not very careful though, and I don't really care where they are going at this stage. I'm not working on the circuit, I'm still on the planning stage. But that should be fine. Okay, now let's keep going on. Before we continue, we just want to make sure that all of our components are somehow locked to the PCB, because we're just gonna flip it over. So I'm just going to bend some of the leads underneath the PCB. Is just gonna take it off from our stand and have a look from this side. So we have our wires here. Yeah, I'm just gonna push them from the top so they sit there nicely, and then bend it a little bit. It doesn't have to be great at this stage. We just want to keep them there, except for the headers. That's because these pins are so thick you can't, well, maybe you can bend them, but it's going to be extremely difficult to do that. And this is all really you need to do on this side. Like, it doesn't have to be perfect. We just don't want them to fall over once we start working our way out. And this is pretty much it. It looks like it's going to work, because I'm just going to pop our PIC 10F here, and I'm just gonna solder like maybe an input and a ground battery here to our low dropout voltage regulator. And that's all I want to do. And I want to expose all of the pins here, starting from this one, like 3.3 volts ground, GP0, 1, 2, 3. That's what I want to do, so it should be fine. Yeah, now we can just flip it over and start working on our connections. I'm just going to use the leads of the through-hole components to create connections here underneath the proto board. So to bend them properly, I'm just going to use our flathead screwdriver. I'm using the legs of the components and the wire to just keep everything together and just solder here and they will be all fine. Now the second one, the second pin of our LDO is our ground connection. Again, I want to do the same thing, so I'm just gonna put it here for a little bit, get a nice long black wire, so this will be our ground. Got plenty of that. Strip plenty of metal so we can work with and pop it in there. It's a fine work. There's some sort of zen to it, just even though, you know, at this age designing PCBs, getting them fabricated is so easy. I still sometimes, you know, like doing wired prototypes like this one. At this stage, because these wires are wiggling so much, I guess it's time to solder some of these things. And if you have like extra long leads like this one, you probably want to use your side cutters. You want to hold on to that before you cut it, because when you cut it, it will just fling, and you can get pretty serious projectile damage with that. So when you're using your side cutters, just make sure you're only cutting one wire and hold it so it doesn't fling. And also you can wear eye protection, highly recommended. I'm just gonna start soldering a couple of things because I don't want stuff to be moving around. And at this point, my solders only will be just to get the physical connection there, just to, you know, hold things in place. I'm not going to solder the whole thing. Once stuff stops moving, it's going to be easier to go there and do rest of the job. Now we need a bit of flux. I have a flux pen here before we start soldering, but you generally want to use it. It makes soldering heaps easier, especially with these lead-free solders, because it's a weak acid and it just gets rid of all the oxides on the metal surfaces, and it just results in better contacts. So I'm just going to apply a little bit before I start soldering at all. Yeah, everything is in place. Now we apply a bit of flux. Yeah, nice. And then we apply a bit of solder to the soldering iron's tip and get in there and just solder it. So at this stage, we have the an input and output caps and our LDO soldered. So actually, we can perhaps test a few things here, and then before going any further, because the rest is just basically a bit of legwork. Really, just need to solder these wires, make sure they're onto the connected to the right pin, so there's no active components, nothing there. Just want to make sure that this works. I'm going to strip the other ends of our cables and test a few things with our multimeter before soldering the rest. You don't want any shorts, and we want stuff to be connected to wherever they're supposed to. Just going to see the resistance here. Yeah, that's pretty normal because it's connected to the LDO. The caps and everything seems to be fine. There's no shorts. We have a high enough resistance. So now we can just apply some voltage to it, perhaps get the LDO working just to test it out. Okay, so I just brought over 5 volts from my USB. A nice 5 volts over here. Now we're going to connect the 5 volts to our regulator. Yeah, we have a nice 3.2894. Yeah, that's close enough. We have a nice 3.3 volts output there. So it's all good. Now we can just get in there and then solder the rest of it and then give it a go. Okay, so we have the regulator stage complete. We have the micro soldered on. Now the trickiest bit is just to solder these headers on. I'm just gonna use one of these alligator clips to hold the headers in place. And yeah, it looks pretty good from all angles. And let's solder that one. I'm just gonna solder one pin and that will just hold the headers in place. Just getting there. Bit of a solder on the tip and pop it in there and solder it up. Okay, and now we just cut that one with the side cutters, just the excess bits, not the solder itself. We don't want to get too much fiddly with the solder. We just want to get rid of the excess wire there. And okay, now this header seems to be sitting there nice and firm. Right, no problems, no gaps between the PCB and the headers, so that's good. And now we can just bend our rest of the wires and bring them to the pins and then just solder the rest of it. Right. Now, I think it's pretty much done deal. Do we have anything excess to cut off? No, it looks pretty good to me. Like we have the regulator stage complete, we have the micro complete, and we have all of the headers soldered to the micro outputs as well as the VDD and VSS. Now let's test our circuit. So let's make sure we have no shorts first. Just going to test the power supply. What kind of resistance we are looking at? 300 kilo ohms resistance in there. It's in line with the what you would expect from the LDO. And now let's look at another thing is just we want to look at it from our micros point of view. So this pin was the VDD, the second pin, and the seventh pin is the VSS. We want to see the same kind of resistance there. It's like, okay, we can see some resistance there too, which is good. And now I just want to check a couple of connections. So I just want to get into the connectivity mode. Okay, and just want to make sure that like VDD Yeah, VDD is connected to our VDD pin, not the VSS. There's just the caps are beeping there a little bit, and also nothing else. Okay, that's good. Now GP0, we expect it to be the next one and nothing else. All right. GP1 is the fourth pin from the top. Okay, and GP2 is the second pin from the bottom. Yeah, and GP3 is the last pin which is connected. So all our connections are good. This is pretty good. Now we can just pop in our pig and then see what's going on. I'm just going to liberate our good old pig from, I don't know, I'm pretty sure there's the Blinky program on it. So we're just going to pop it in there. So one of these things with these IC sockets is that it's actually quite difficult to, especially these smaller ones, could be quite difficult to put the chips in there. So we just need to like just a little bit bend the pins of your micro just a little bit, and then don't push it too hard, like, you know, push it a little bit each time from each end, bottom and top. And yeah, that's it. We have the micro there. Now we just want to, I didn't connect an LED there because I want to use some jumper wires to connect the LED somewhere else. I have some project in mind to do with this one. But just again, we need the help of our breadboard a little bit. Let's see if I can find some female to male cables. I want the GP0, which is this one, and I want the ground as well, because I think there was a connection there, and I want to test our LED, which is, yeah, there's like a current limiting resistor here. I'm just testing the, okay, yeah, it works. So I didn't solder the LED on there because I have some plans in mind. Just want to move this LED to somewhere else and keep the circuit somewhere else. But you can definitely go ahead and solder it in there with the current limiting resistor, whatever you want. But yeah, our wired prototype works with his internal regulator and everything. So that's pretty much it, folks. Sorry about the mess. There's like a lot going on, but and you actually see that how tedious it is. It's not. I mean, it's fun. It's not that difficult. You can just make it in a couple of hours, and this is like a very simple circuit. Like it's as simple as it gets. So I mean, still a viable option. But if you have like a little bit more complicated circuits, you probably want to go to the PCB route, getting that manufactured, because it's quite straightforward as well. Let me know if you have any questions, and thanks for watching. See you next time. Bye.